to make a skyscraper taller. You build up. You add steel, you add glass, you just keep stacking. But to make a plant taller and actually keep it alive to support its own weight, sometimes you have to violently chop off its head.
Yeah, it's a completely profound shift in perspective.
Right.
I mean, we usually think of growth as this purely additive process. You give a plant water and sunlight and it adds mass. But strategic cultivation is, well, it's often subtractive. You actually have to remove a piece of the present to secure the future.
Welcome to today's deep dive. We are so glad you are here with us. Today, we're stripping away the mystical idea of the green thumb, and looking at the raw mechanics of botanical success.
Absolutely.
We're pulling from a highly specific, deeply insightful blog excerpt that was published in late April 2026, April 28th to be exact. It's titled, "The Architect of Robust Vincas."
And that's from a massive ongoing series, right?
Yeah, it's called Notes on Gardening, specifically part 879, and it's written by a writer who goes by Ang.
Ang is observing a very specific subject here, which is the Madagascar periwinkle.
Scientifically known as Catharanthus roseus, or, as most people in the gardening community call them, Vincas.
Right.
So our mission today is to explore how a single close-up observation at a local plant nursery completely changed Ang's approach to cultivating these plants. We are going to unpack how this really short text holds a masterclass in shifting your strategy to solve a frustrating problem.
And, this isn't just about plants. It is a brilliant case study in diagnosing a systematic failure. Because Ang is dealing with a problem that just persists, no matter what the starting conditions are.
Okay, let's unpack this. Ang writes to the internet, laying out this intensely frustrating pattern. These Vincas, regardless of how they begin their life, inevitably develop into what Ang describes as leggy.
Leggy, right?
Yeah, the text specifically points out elongated, spindly branches and thin, fragile stems.
Which, for anyone listening who has ever bought a lush, bushy basil plant from the supermarket, only to watch it turn into a fragile, drooping string bean 2 weeks later on your kitchen counter.
Oh, totally. The worst.
Yeah, you know exactly the heartbreak Ang is documenting. The plant is alive, technically, but it's structurally compromised.
It feels a bit like baking bread at home, right? You follow the steps, but it never quite looks like the bakery's loaf. Why does Ang keep hitting this wall of fragile and leggy growth, despite trying, 2 different starting methods?
What's fascinating here is that Ang is actually applying a really systematic approach. Ang documents that this happens regardless of origin.
Right, from seed or mature plant.
Exactly. Ang tries growing them from seed, they get leggy. Ang buys them as mature, seemingly healthy plants from a store, and given some time, they also become spindly and fragile.
So it eliminates the easy excuse. You can't just say, oh, I got a bad batch of seeds, or the garden center sold me a dud.
Precisely. By ruling out the source of the plant as the root cause, Ang proves the issue must lie in the cultivation method over time. There's some environmental or mechanical factor during the plant's time in Ang's care that actively encourages this weak vertical growth.
I want to focus on that word, leggy, because it paints such a vivid picture. Biologically speaking, what is a plant actually doing when it gets leggy? Like, why would an organism build itself so poorly that a strong gust of wind could just snap its main stem in half?
Well, it comes down to an evolutionary imperative that is fundamentally at odds with what a gardener wants. In nature, a young plant is usually competing with a dense canopy of other plants for sunlight.
Right.
So its primary desperate directive is to reach the light source as fast as possible. So it pours all of its biological resources into rapid vertical extension. It stretches the spaces between its leaves, those spaces are called internodes, trying to outpace its neighbors.
So it's sprinting for the finish line, but completely forgetting to build the skeleton it needs to actually stand upright once it gets there.
Yeah, that sprint comes at a massive structural cost. The plant neglects secondary growth, which is the thickening of the stem. It doesn't bulk up its vascular tissue, it just reaches. The plant's goal is to survive long enough to drop a seed. But the gardener's goal is to cultivate a robust, aesthetically pleasing, self-supporting structure. And until the gardener intervenes, those two goals are in conflict.
So Ang is stuck in this frustrating loop. Seed to spindly, mature plant to spindly. The evolutionary sprint is winning. But then the narrative shifts, right?
Right.
Ang takes a trip to the local plant nursery, and this is where the detective work kicks in. Ang spots a batch of professional Vincas that look completely alien compared to the fragile things at home.
Yeah, these nursery plants are described as having incredibly thick, strong main stems.
Here's where it gets really interesting. Most of us would look at those professional plants, feel a deep pang of jealousy, hand over our credit card, and just take them home.
Only to watch them eventually succumb to the same spindly fate.
Exactly. But Ang stops. Ang leans in and literally examines the physical anatomy of these successful plants. And that close-up inspection reveals the secret.
The pruning.
Yes, Ang notices that the very tips of these massive, sturdy nursery plants had been pruned long ago.
The deliberate severing of the apical bud. This is where we transition from casual observation to actual botany. Ang has stumbled upon the visible evidence of manipulating a mechanism called apical dominance.
Okay, break that down for us. Apical dominance. What is actually happening inside the stem when you sever that top bud?
So the main growing point at the very top of a plant stem is called the apical bud. This bud is basically a chemical factory. It produces hormones called auxins.
Okay.
These auxins travel downward through the stem, and their primary job is to actively suppress the growth of the lateral buds. Those are the little nodes on the sides of the stem that want to become branches.
Oh, wow. So the plant is chemically sedating its own side branches so it can focus all its energy on going up?
Exactly. It's a ruthless allocation of resources. The auxins say, do not grow outward, we must only go upward toward the light.
Right.
But when a gardener comes along with a pair of shears and physically cuts off that apical bud, they are removing the auxin factory. The downward flow of that suppressing hormone stops immediately.
The chemical sedative wears off.
And the lateral buds wake up. Without the auxins holding them back, those side nodes burst into action and begin growing outward into thick side branches.
Think of the plant's growth like a highway. If you set up a roadblock on the main highway by cutting off that top tip, you force all that botanical traffic to detour down the side streets. And that extra traffic is what pays a wider, stronger main road.
That highway analogy works perfectly. But we need to take it one step further to explain the strong main stem Ang observed.
Oh.
It isn't just about traffic detouring down side streets. When those lateral branches start growing vigorously, they demand a massive increase in water and nutrient delivery from the root system.
The infrastructure has to upgrade.
Yes. The main trunk now has to support the weight and the biological demands of a wide, sprawling canopy rather than just a single vertical stalk.
Makes sense.
So to handle that load, the plant undergoes intensive secondary growth. It adds layers of structural tissue, xylem and phloem to the main stem. The detour of your botanical traffic literally forces the main road to pave itself wider and thicker.
So you sacrifice immediate vertical height for long-term foundational stability. You have to hurt the plant in a controlled way to stop its natural flimsy sprint.
I want to draw your attention back to a specific phrase Ang uses in the text because it's the linchpin of this entire operation.
Which one?
Ang doesn't just note that the plants were pruned. Ang specifies they were pruned long ago.
Pruned long ago. Because, you can't just chop the top off a 3-foot-tall spindly plant and expect the base to instantly turn into a tree trunk.
Exactly. Building a strong foundation isn't a quick fix. Time is the unyielding variable. Pruned long ago tells us that achieving that robust look requires early intervention and patience.
Right.
The nursery professionals made that crucial, counterintuitive cut when the plant was very young. They halted its upward momentum almost immediately after it established itself. If you wait until the plant is already leggy, cutting the tip off will just give you a tall, weak plant with a few awkward side branches.
The structural damage is already done. So what does this all mean for Ang's current plants? Because Ang maps out a project for an upcoming long weekend, right? Deciding to experiment and implement this tip pruning method strictly.
Yes, a dedicated block of time to completely overhaul the cultivation strategy.
But Ang specifically mentions propagating to cuttings now instead of seeds. Why pivot to cuttings just because you learned a new pruning trick? If Ang's current plants are fragile and spindly, and a cutting is literally just a cloned piece of that exact same plant, aren't you just cloning a failure?
It's a totally fair question.
Right. Why not just throw the weak plants in the compost bin, buy fresh seeds, and start the early pruning process on a brand new plant?
If we connect this to the bigger picture, Ang is synthesizing knowledge. If you build a house with rotten wood, chopping off a piece of that wood to start a new house doesn't solve your lumber problem. But plant biology doesn't work like carpentry. We have to introduce a concept called tubitancy.
Tubitancy, break that down.
Plant cells are incredibly plastic. Unlike most human cells, many plant cells retain the genetic ability to become an entirely new plant. When Ang takes a cutting, snipping a few inches off the end of one of those spindly branches, and placing it in soil or water, a radical cellular shift occurs.
The plant realizes it has been severed from its root system.
And it goes into survival mode. The cells at the cut end de-differentiate. They transform into root tissues. They push out brand new roots.
Okay, I'm tracking.
So here's the crucial part. While the cutting contains the exact same DNA, it does not inherit the structural history of the parent plant.
Oh, so it's not a miniature version of a leggy plant. It is a biological reset button.
It resets the structural clock to zero. Ang is combining a new starting method, cuttings, with the newly observed structural technique, tip pruning, to essentially re-architect the Vincas from scratch.
That is brilliant. Once that cutting roots and pushes out its very first bit of new top growth, Ang is going to sever the apical bud.
Precisely. Ang is mining past mistakes for the raw materials to build success. It's a deeply proactive response to a long-standing frustration.
So let's summarize this journey for you listening at home, because the narrative arc hidden in these few paragraphs from Ang's blog is just incredibly dense. We started with the frustration of fragile, spindly Madagascar periwinkles, right? Trapped in a cycle of elongated, weak growth.
A baseline of systematic failure that Ang meticulously documented.
Then we get the pivot, the nursery trip. Instead of just admiring the robust plants, Ang leaned in and looked for the mechanics of that success, finding the empowering realization that a strong main trunk requires deliberate, early pruning of the tips.
Recognizing that removing the apical bud fundamentally alters the plant's hormonal balance.
And finally, the application. A technique Ang is now excitedly taking into a long weekend of propagating cuttings, hitting the biological reset button on the current plants. It is a complete paradigm shift.
I think the most vital takeaway for anyone listening to this deep dive is the immense value of close observation. We are socially conditioned to look at an end result, like a massive, sturdy plant, and we just accept the surface-level aesthetic.
We assume the magic green thumb.
Exactly. But the gap between an amateur's frustration and a professional's robust success was bridged simply by looking closely at how the successful plant was structured. If you look closely at anything truly robust, you will almost always find the places where early pruning happened.
Look for the scars of success. That is a fantastic framework. Which brings me to a final thought I want to leave you with today. We started this deep dive talking about the myth of innate talent, the idea that some things just magically grow strong without intervention. Ang's notes prove that in the physical world, strength is often engineered through deliberate early restriction.
It really is.
So I want you to step out of the garden for a second. If physically cutting off the leading tip of a young plant is the only biological way to force it to build a trunk strong enough to support its future weight, where else in your own life or work might introducing a deliberate early limitation actually force you to build a much stronger foundation?
It is a heavy question. Sometimes stopping the forward sprint is the only way to ensure you don't collapse when the wind blows.
Sometimes the roadblock is the only thing that gets the highway built properly. Thank you so much for joining us on this deep dive. Keep observing the architecture of the things around you, and we'll catch you next time.